38. I'm just going to go ahead and do the whole thing because I have to anyways. Y equals x squared times the square root of 3 minus x. So we're trying to find the critical points and then identify them again, right? So we're going to take the derivative, dy dx. Product rule again, derivative of x squared is 2x times the square root of 3 minus x minus x squared over 2 times the square root of 3 minus x. Where did this minus sign come from? Yeah, the chain rule from the negative inside the square root. Okay, and then the negative 1/2, that just sends my denominator, my square root to the denominator. Alright, if I set this equal to 0, we get just, actually here, I'm just going to do this. I'm going to do a couple of things at once. Alright, by the way, Ted, feel free to walk in front of the camera whenever you want, you know. For sure. Go around. Alright. I'm sorry. You better be. Alright, so I set equal to 0 and I moved the term on the right over. You see that okay? And then we're going to cross multiply to give us x squared equals 4x times 3 minus x. Good work. Then x squared equals 12x minus 4x squared. So we get 5x squared minus 12x equals 0. Factor out an x to get 5x minus 12 equals 0. So that means x equals 0, or 5x minus 12 equals 0, which implies x equals 12/5. So those are my two critical points. So here's the part that Seth was asking about, the analysis. So doing it the same way I did earlier is we draw this line, and on that line we've got the point 0 and the point 12/5. So we pick a point in each of these regions and plug it into the derivative, which is, I'm going to think of it as this part of the derivative. So if I plug in a negative number, I will have a negative times another negative, and a negative times a negative is always a positive. So I don't really care what number I pick, and I'm not looking to find the exact number. I'm just trying to find out if it's negative or positive. Plug in a number between here, like the number 1. When I plug in the number 1, we get a positive times a negative. So that makes this negative. And then bigger than 12/5 is like the number 3. Plug in 3 and you get a positive times a positive, which gives you a positive. Most of the time you get this scenario where it alternates. Okay? The only time you wouldn't get that scenario is if you get something like this, where your critical point is also an inflection point. And then you may get like, you know, positive, 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 positive. But most of the time it does alternate. Right? Because if it alternates like this, you go positive, negative, positive, you know, something like that. Okay. So that means that at 0, we're at a max, and at 12/5, we're at a min, because the tangent lines.
It's amazing how more symbols
Right,
you
that's a
get.
positive, that's a negative, that's a negative, that's a positive. So 0 is a max, and 12/5 is a min. And there you have it.
And then you just plug it back into the function to get that.